Hey guys, welcome back. We're actually going to put two lessons together, Lesson 8-2 and Lesson 8-3. And we're going to talk about function rules. So how do we actually create the pattern that shows what the input was and what the output was. And we're also going to talk about sequences and graphing. Okay, so kind of all the different things that you can do with functions. And again, this is very introductory in that you will continue to learn about functions throughout future math classes for many, many years. All right, so let's talk about we talked a little bit in our first set of notes about a function rule, and it basically is telling you what to do to the input so that you can get the output. Okay, so a function rule, let's do a different color. It's no, not like, let's say it's an expression or equation. So expression, remember, has no equals in it. Or equation that tells how to get an output from a given input. Okay, and we did that in our first set of notes. So today we're going to talk about, I'm going to give you that function table, and your job is to try to figure out the rule, okay? And sometimes the rules are going to be one step, one operation done, and sometimes it's going to be more than one operation. So let's talk about some other vocab before we get in. Let's talk about what is a sequence. And we're going to use this idea of sequences and particular kinds of sequences in order to figure out the rules. So a lot of observation is going to be taking place. So kind of like a math scientist, if you get that. A list of numbers in a specific order following a pattern. So that pattern turns into our rule. So I'm going to put rule here, okay? So there's forgot about this word, term. And we talked about this back in expressions and equations. So term is each number in this particular case in a sequence. And when we were talking about terms before with expressions and equations, it was each part of the expression, the things that were separated by adding signs and subtracting signs, or in an equation, same thing. So we have two major sequences that we're going to be looking at. So I'm going to do half on the left and half on the right. So we have, I know this looks like arithmetic, but it's arithmetic. You'll get that later. Arithmetic sequence. Oops, that's the weirdest. I did a C and an E together. So that's this side, and the other side is going to be a geometric sequence. Now, what is the difference between these two sequences is the math pattern. Okay, so it's pretty basic. You guys are probably pretty familiar with arithmetic sequences. So in arithmetic sequences, you're going to add or subtract the same value to determine the next term. So in other words, these are patterns that use adding or subtracting. So let's go ahead and we'll do one of each, okay? So let's do this guy. We have this sequence of numbers, 7, 14, 21, 28, and then bump, 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 bump. Oops, I don't know why I have dots there. I'm going to get rid of those dots. Oh, I know why. Bump, bump, bump. So what we're going to do is look at something. Now, how do I know whether it's an adding or it's a subtracting? So here's a clue. If it's an adding pattern, the numbers increase. Okay? If it's a subtracting pattern, then the numbers decrease. So anytime I'm looking at a sequence, the first thing I'm going to assume it's that it's an arithmetic one, that I'm either adding or I'm subtracting. So let's go ahead and let's test this guy out. So to go from 7 to 14, I would add 7. To go from 14 to 21, I would add 7. To go from 21 to 28, I would add 7. So I would say that this sequence, or the pattern, is plus 7, okay? So that tells me if I want to figure out the next 3 numbers in this sequence, I would add 7. So that would give me 35. And if I added 7, oops, it doesn't look like an add sign, it looks like a multiplication sign. That would give me 42. And if I were to add 7, that would give me 49. So a lot of times you're asked, well, what are the next 3 terms in the sequence? There you go. Okay. All right, so let's do a subtracting one. And sometimes the numbers aren't just whole numbers. We have 4.5, and then we go to 4, and then we go to 3.5, and then we go to 3, dot, dot, dot. So notice that my numbers are getting smaller. They are getting smaller. And what am I doing? Well, it looks like I'm subtracting 0.5. Subtracting 0.5. Subtracting, oops, look, I was going to do division, 0.5. So you see what's happening, and it's usually easier to see it when you go for some people, from a non-whole number to a whole number. Sometimes you can see the pattern more easily. So you don't have to go from the beginning of the pattern. You can go anywhere in the middle of the pattern to look for what you think the rule is, and then go back and apply it to all the terms and see if it's true. So on this one, we're going to continue. If we continued the process, and I'm going to do a different color here. We'll go darker. If we subtract 0.5, that's going to give me 2.5. And if I subtract another 0.5, that's going to give me a 2. And if I subtract another 0.5, that's going to give me 1.5, and so on. Okay? So that's an arithmetic sequence. A geometric sequence, we're going to use the other 2 operations. We're going to oops, sorry, forgot to change my color. Let's try that again. Let's see. We're going to multiply or divide by the same value. To determine the next term. Okay. So again, the same sort of idea that worked before is going to work here. So it's going to multiply, would be the pattern, if the numbers increase. we are going to divide if the numbers decrease. And I can just hear right now, you're like, well, wait a second, how do I know when it's multiplying or adding? Well, let's do a problem and you can see it. So let's start with this sequence. So we have 2, 4, 8, 16, ... So if I were to assume this was an adding pattern, I would add 2, but this one says to add 4, and this one says to add 8. So I can tell it's not an adding pattern because for it to be an adding pattern, it'll have to add the same amount every time. So I'm going to have to forget all of that, and we're going to try a different tack. We're going to try multiplying. So let's, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So that's what I would do, and I would continue the pattern. So if I multiplied 16 by 2, I'd get 32. Multiply 32 by 2, I get 64. Multiply 64 by 2, and now I get 128. Okay? So what would a division pattern look like? Let's do, so let me write over here, sorry. The pattern, oh, I didn't do it over there either. The pattern is multiply by 2. And I forgot to write it over here on the left. The pattern is subtract 5/10. Okay, so let's look at a pattern where it would be division. So let's do 27, 9, 3, 1. And so again, I see if I subtracted, I'd have to subtract 18. And here I would subtract 6. So already it tells me it can't be a subtraction pattern. So then I look, and is there a different pattern? So if I divide by 3, 27 divided by 3, I get 9. If I divide 9 by 3, I get 3. If I divide 3 by 3, I get 1. So the question is, what do I get when I divide 1 by 3? So if I continued on that pattern, I'd get 1 divided by 3. And if I divided that by 3, it's kind of, I'm going to write it over here. So dividing by 3 is the same as multiplying by 1/3. So a lot of times people don't talk about a division pattern, they just talk about multiplying by a fraction. And so if I think about it like that, if I multiply 1/3 by 1/3, I get 1/9. So I'm dividing the denominator, or I'm dividing that fraction, and I'm getting it to be smaller and smaller and smaller. So I can say the pattern is to divide by 3. I'm going to do a little lighter color here. Or multiply with 1/3. Okay? All right, so let's do some practicing of this on my next screen. This would be my second page of my notes. So I'm going to rewrite the title. I'm going to pause. Okay, so what we're going to do is look at a input-output table, okay, a function table. And we're going to see if we can determine the pattern. So our directions are going to say write the rule in words and symbols, which would be a way of saying an expression, or it could be equation. And then find the 8th term. Okay, so let's do input. Do this number 1. Output. And so our input is going to be what we would call X, and our output would be what we would call Y. Okay, I'm going to box this up, and let's see, we're in 1, 2, 3. 1, 2, 3, 4. Okay, so here come my input numbers. These are the numbers that I am going to put into some mystery rule. Actually, I want to do one more box. Boom, boom, boom. And what we're going to put in the last one is N. So that's going to stand for any number in the sequence. So just a number in the sequence. Okay, and then we're going to be told the output numbers. So when I put in 1, I get out 8. When I put in 2, I get out 16. When I put in 3, I get out 24. When I put in 4, I get out 32. So I want to try to figure out how do I get those values. So first thing I would do is look at if I'm increasing or decreasing on my output. So my output increases. So that means one of two things. It's either an adding or multiplying pattern. Okay, so that's the first thing I look for, my output. Next thing I'm going to do is, what do I do to X? So what happens to the input to equal output? So I'm going to be looking from top to bottom. So what could I do to 1 to get to 8? So if I added 7 to 1, I would equal 8. So if I had an addition pattern, would that work every time? So let's try it. Is 2 plus 7 equals 16? But it's not supposed to equal 16. It's supposed to equal, or it does equal 9. Okay, so when the adding pattern doesn't work, that's when I try a multiplying pattern. Okay, so we scratch the adding, and let's try multiplying. So 1 times 8 equals 8. 2 times 8 equals 16. Yes. 3 times 8 equals 24. So what we've just discovered is the pattern. So the pattern is you multiply by 8. So what do we get over here under my rule? What am I going to do? I'm going to take whatever number I am in the sequence, whatever number that is, and I'm going to multiply it by 8. Okay, so there's my rule. So then, if I want to find the 8th term, I'm going to let n equal 8. So my rule, 8n, becomes 8 times 8, or 64. So that would be the 8th term. Okay, let's try another one. And this is, where things get a little bit tricky, okay? Let's see. Let's do input, output. reminding ourselves that the input is the x value and the output is the y value. Okay, so this is the first answer we're looking for, is what's the rule? And if I wanted to, I could write that let's go back. Let's write that as an expression. If I wanted to write that as an expression, I would say I would get my output. Circle that up. So my output would equal 8 times my input. So that's in words, okay? And in an expression, I could write it. I'd write y equals 8x. I could write it that way, okay? Or, yeah, I'd say that's good enough. Okay. I seem to have a little blotchy right here. Let's get rid of him. Okay, so let's go back to our table over here. It's still early. I haven't had all my coffee yet. So let's see, we want 1, 2, 3, 4, 5. My table. And we go, let's change the colors. So my input numbers are 3, 4, 5, 6, and then we're going to have the n. Any number. And then the outputs are 7, 8, 9, 10. Okay, so one thing I do notice is that I am increasing. So the outputs increase. So what I could have is an adding or multiplying pattern. Okay, so where I want to look is how do I get from 3 to 7? Well, if it was an adding pattern, let's try adding. So if I had 3 and then I added 4, that would equal 7. So this is what I'm thinking the pattern is. So let's test it. 4 plus 4 equals 8. Good. 5 plus 4 equals 9. All right. And then 6 plus 4 equals 10. So each one of these gave me exactly what I needed. So what I'm going to do is I'm going to take my any term, and then my pattern is I'm going to add 4. Okay, so my pattern is to add 4, and I could write it this way. The output equals the input plus 4, or y equals my input x plus 4. So those are two ways to write that. Now I'm going to go on to the next screen and we're going to do another one, and this one is the toughest of them, okay, where the pattern is not very obvious. So then we're going to have input, we're going to have output, we're going to have, I'm going to hold off and put my little letters there. So this is our x, and this is our y. Okay, and then we have 1, 2, 3, 4, 5. And then my input values are, 1, 2, 3. We have one of the last boxes here. Sorry about that. I was going through a pattern and not even looking at what my notes said. Okay, and then here are my outputs. So I've got 5, 7, 9. Okay, so we definitely have an increase. So outputs increase, so that means it's either going to be an adding or multiplying pattern. All right, so let's see. If I did that, I'd have 1 plus 4 equals 5. So 2 plus 4 equals 7. No, it doesn't. Okay, so it's not an adding pattern. So if I tried multiplying, 1 times 5 is 5. So 2 times 5 would equal 7? No, it doesn't. So when it doesn't fit a clean pattern, then what I need to do is to do a combination. I know, it's scary. So let's see what we can come up with. So we're just going to play with numbers for a moment. So the 1 to 5 is a hard one to find a pattern with. So let's see what we could do to get from 2 to 7. So let's see. If I doubled it, that would give me 4. And if I added 3, that would get me to 7. All right, so that's my initial hypothesis, would be that I would multiply by 4, and then I would add 3. So I'm going to go back and, or no, I multiply by 2. Multiply by 2, I got 4. And then I added 3. So let me go back and test it. So if I have 1 times 2 is 2, and I added 3, I get 5. Okay, that's good. Let's try the next one. So 3 times 2, that is 6. If I add 3, I get 9. Ooh, I just figured out the pattern. So the pattern is I'm going to take my n number, whatever number the input is, I'm going to double it. Actually, I'm going to make this not big enough for me to write everything, so I'll just make it a little bigger. And then I'm going to add 3. So this one is just total math sleuthing, okay? So I'm going to get to the output, let me change colors. I had to take my number and I multiplied it by 2, and then I added 3, okay? So I double my input. Let me try this again. Double input, add 3. So this would be y equals 2x plus 3. So this is the challenging one. When a simple adding pattern doesn't work for all of them, or a simple multiplying pattern doesn't work for all of them, that's when you need to do a combination of them. So start with multiplying and then adding. Sometimes you can multiply and then subtract a number as well. So now you might be saying, okay, that's fabulous. What does this have to do with graphing? Okay, let's get to that, and that'll be the end of these notes. And I know these are long, and I'm so sorry. So first off, we're going to graph. We're going to need to make sure that we have we can take our function rule. Our function rule is going to form an equation. Okay? And so the equation is kind of like what I was demonstrating with the pattern, y equals something happening to the x and then something else. And then we're going to create ordered pairs. And those ordered pairs are just going to be made up of your input value followed by your output value. Okay? And then we're going to graph the ordered pairs. Okay? So, bottom line is, if you have already an input-output table, so let's do that. And our inputs are 1, 2, 3, 4, 5, and our outputs are 9, 18, 27, 36, 45. You could try to see, I'm increasing. I can tell that if I added 8, 1 plus 8 is 9, 2 plus 8 is 10, not 18. So it's not an adding pattern, it would be a multiplying pattern. So 1 times 9 is 9, so 2 times 9 is 18, 3 times 9. So basically my rule is going to be y, that's my output value, remember, equals 9 times my input value, okay? But just based on what I'm seeing, I can grab these numbers here and form ordered pairs. 1, 9, 2, 18, 3, 27, 4, 36, and 5, 45. Okay, so I'm going to go ahead and graph this. And I notice all my numbers are positive, so I'm just going to be working in the first quadrant. Now I'm going to use different scales. On the x-axis, my inputs just increased from 1 to 5. Oops, almost put 5 there because I was thinking 5. And these all on your x's increased by 9s. So this is 9, 18, 27, 36, 45. Now, since each input has exactly one output, what you should get every time you graph a function is the same kind of graph. You would get a line. So functions, graph, lines. Okay? And so if they don't give you the function table, so we'll go one more screen, but they give you a rule and they ask you to graph, they give you y equals 3x plus 2. Well, now what you're going to do is create your own table with inputs. You have a work column, outputs, and ordered pairs. So I would suggest you choose simple inputs, just positive ones, and then every time you see the x, you're going to substitute in your input and calculate out your output. So this gives me 0 plus 2, which equals 2. So you have 0, 2 as one ordered pair. Next one, we have y equals 3 times 1 plus 2. That gives me 3 plus 2, which equals 5. So input, output. And then the last one, y equals 3 times 2 plus 2. So I'm just following the rule. And that gives me 6 plus 2, or 8. Input of 2, output of 8. So then I'm going to go ahead and I'm going to graph this. Again, first quadrant, since all my numbers are going to be positive. And I'm going to go 1, 2, boom. And then we're going to go 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to put in every other number. And then I'm going to graph my ordered pairs. So when I put in 0, I got out 2. When I put in 1, I got out 5. When I put in 2, I got out 8. You really just need 3 points to do a line. If you only choose 2, then if you did a calculation error, you'd still get a line, but it might not be the right one. All right, guys, good luck with this one. See you later. Bye.